In this lesson, we're going to go through the rules of exponents and how to work with simplifying expressions involving exponents. First, let's go through the basic rules, and then we'll get into 20 examples that I encourage you to practice on your own, and we'll go over them together and we'll get some experience and some practice. But first of all, let's just kind of go over a review, or if you haven't learned these, when you raise a non-zero number to the 0th power, it always comes out to 1, and I'll show you why that is in just a minute. When we have a negative exponent, what that negative exponent tells us to do is to take the reciprocal and then you would raise it to a positive exponent. So for example, if you had, let's say, x to the negative 3rd power, you can think of this as being a fraction, like anything can be written as a fraction by putting it over 1. When you see that negative exponent, what that tells us to do is to take the reciprocal, or you can move it to the other side of the fraction. That's like taking the reciprocal. So this becomes 1 over x to the positive 3. Now similarly, if you had, let's say, 1 over, let's just say, x to the negative 5, you can take this quantity here and move it to the numerator. That's like taking the reciprocal, and that's going to be x to the 5th over 1. So basically, when you see that negative exponent, take the reciprocal or move it to the other side of the fraction bar and make it a positive exponent. Now here, where you're multiplying, if these bases, these numbers here, are the same, then what we do is we add the exponents. So x to the m times x to the n is equal to x to the m plus n. And let me just show you quickly why that is. And the reason I'm showing you is because if you ever get stuck on some of these problems and you're trying to figure out, like, what's the right way to approach it, think about it like this: x squared times x cubed. X squared means we have 2 x's multiplied together. X cubed means we have 3 x's multiplied together. How many x's are multiplied together? Well, you can see if you count here, we have a total of 5. You don't want to have to write this out every time. It takes a little bit of time. The shortcut is just, oh, I'm multiplying, so I just add the exponents. This is just a way to kind of remind yourself. Now, when you're dividing and the base is the same, see how these are both base x? When you divide, you subtract the exponents, and keep in mind the order is important. So you want to take the numerator's power minus the denominator, so x to the m minus n. And I'll show you why that is. Say, for example, if you had x to the 4th divided by x to the 1st. So x to the 4th we know is x times x times x times x, 4 x's. X to the 1st is just 1x, and we can see that one of these x's in the numerator cancels with one of them in the denominator, and we're left with x to the 3rd power. Now the shortcut is 4 minus 1 is 3. Now sometimes when you're doing this, a quotient rule, when you divide, you subtract. If you ended up getting a negative exponent, then we could do what we did over here, which is to take the reciprocal and move it to the other side of the fraction on the next step. Now, what would happen if you had, let's say, x squared divided by x squared? Well, you can see 2 minus 2 is equal to 0, and we can see here that anything to the 0th power is equal to 1, which makes sense because how many times does x squared go into x squared? 1 time, or anything divided by itself is 1. So that's why when you see anything to the 0 power, we say that it's equal to 1. Now, how about this one where you have a power raised to a power? So if you have x to the mth raised to the nth, that's x to the m times n. Now let's take a look at that. So for example, if we had, let's say, x squared cubed, what does that really mean? Well, that really means that you have 3 of these x squareds. So you have an x squared times x squared times x squared, which is 2 plus 2 plus 2, which is x to the 6th. So power to a power, we multiply. And then this last one here, when you have a fraction raised to a power, what you do is you take that numerator to the nth power and the denominator to that nth power. So that's basically just like applying it to the top and the bottom. So we're going to go through 20 examples. Let's see if we can practice together, and let's dive into the examples. Okay, see if you can take a snapshot and try these problems on your own. We'll go through them together. Let's start with these first 6, and then we'll practice. So what did you get here for number 1? 72 to the 0th power. Well, this was kind of an easy one. We talked about at the very beginning, anything to the 0th power is equal to 1, as long as this base here is like a non-zero number. So here you can see anything to the 0 equals 1, and we're done. We're going to start with some easy ones, and we're going to gradually get more challenging. So if these are too easy for you, just feel free to skip ahead. Now for number 2, 3 to the negative second power, what do we do on that one? Well, remember when we see this negative exponent, what it tells us to do is to take the reciprocal. So we say, this is really like 1/3 to the positive 2. And we can say, well, 1/3 times 1/3, when you square something, it's like multiplying it by itself, like having two of them multiplied together. You're going to get 1/9. Or another way to think about it is you can think of this as being over 1. And when you have that negative exponent, you can move it to the other side of the fraction. This is the way I like to do it. And then raise it to the positive exponent. So that would become 1/3 to the positive second, and 3 squared is 9. So either way, you're going to get 1/9. Okay, for number 3 here, we've got 5 to the negative third and negative 2 to the 0. Now this one's a little bit of a trickier one because remember your order of operations, the parentheses, exponents, multiplication, division, addition, subtraction, the PEMDAS. Well, here you want to do this exponent first and then multiply by this negative second because it's not in parentheses. So we'd say 2 to the 0 is 1. 1 times a negative is negative 1. So what we have is a negative 1 here. And then this 5 to the negative third, because we have a negative exponent, what I'm going to do is I'm going to move it to the other side of the fraction and make it a positive exponent. Of course, there's only going to be like 1 left here because 1 times anything is itself. So that 5 to the negative third comes down here and it becomes 5 to the positive third. Well, we know 5 cubed is 5 times 5 times 5. It's 125. Times this negative is a negative 125. So this comes out to 1 over negative 125, or you could just say it's negative 1/125th, like that. Okay, for number 4, this one's kind of interesting because this is a negative exponent and this also has a negative exponent. So this one in the denominator, I'm going to move to the numerator. The one in the numerator, I'm going to move to the denominator. That negative tells us to take the reciprocal. So this is going to become 3 to the positive 2 over 2 to the positive 3. Of course, 3 squared means 3 times 3, like 3 twice, so that's 9. And 2 cubed is 2 times 2 times 2, which is 8. And so we're getting 9/8 for that one. Okay, for number 5, what did you get for this one? Now this one, what I would do is I would think of this as being a fraction by putting it over 1. This x to the negative 2, I would move that to the other side of the fraction and make that a positive exponent. So this ends up coming out to 4y cubed all over x squared. And for number 6, what did you get on this one? Now, I like to put a little line through my z's just so it doesn't look like the number 2. So for this one, you can see this y to the negative third, it's going to come to the denominator because of that negative exponent. And the z to the negative fourth is going to go to the numerator because it has a negative exponent. That negative tells us to take the reciprocal, but the shortcut is just to move it to the other side of the fraction. So that's 2x squared z to the fourth all over y cubed. Okay, continuing on, see if you can take a snapshot and try these next group of problems. For number 7, what did you get for this one? We've got 3x times 2x to the negative third. So here you can see we're introducing some numbers, some variables, and what you want to do is you really want to multiply these numbers together. 3 times 2 is equal to 6, and then the variables together. Remember, if you don't see an exponent, that's understood to be a 1. Sometimes it helps just to write that in there. And then if you multiply, remember, what do you do when you multiply? You add the exponents, so this is going to be x to the negative 2. We really want to write our final answer with only positive exponents. So what we can do here is we can think of this as being over 1. When we have a negative exponent, we can move that quantity to the other side of the fraction. That's like taking the reciprocal. So we're going to be left here with 6 divided by x squared, and you got that one. Okay, for number 8, what'd you get for this one? Negative 2, the quantity cubed, times negative 2. Again, if you don't see the exponent, you can always put a 1 in there, because there's only one of them. And when you multiply and you have the same base, what do you do to the exponents? You add them, because we've got 3 of these, 1 of these, we've got 4 of these. Now what's interesting about this problem is you see how this whole thing is in parentheses, and you have a negative to an even power. So imagine if you had a negative times a negative times a negative times a negative. 4 negatives, that's going to multiply to a positive. So if you have a negative to an even exponent, it'll be positive. If you have a negative to an odd exponent, like a 3 or a 5 or 7, is going to be negative. 2 to the 4th we know is 2 times 2 times 2 times 2, which is 16. So this is just going to be positive 16. Okay, for number 9, what did you get for this one? X to the negative 2, the quantity cubed. Remember, when you have a power to a power, an exponent raised to another exponent, what do? We multiply, so negative 2 times 3 is negative 6, and we don't want that negative exponent, so we can move it to the other side of the fraction and make it a positive exponent. And you got that one. Okay, so for number 10, what do you think on this one? We have 2x the quantity cubed times 3x squared. Now you can do these problems in steps. Some people are really good at doing them all in their head in one step, but I would think of the PEMDAS like parentheses, exponents, then multiplication, kind of follow that order. So here what we have is, we can actually think of this as x to the first and 2 to the first. Power to a power, we multiply. So this is actually like 3 times 1 and 3 times 1. So that's going to give us 2 cubed, which is 2 times 2 times 2, that's 8. 1 times 3 is 3, so that's 8x cubed. And then this is still 3x squared. We're going to multiply the numbers together. 8 times 3 is 24. And then x cubed times x squared. Remember, when you multiply, you add the exponents. So that's going to be x to the 5th power. Okay, for number 11 now, this one's kind of interesting. We have the quantity 2x raised to the negative 4th power. So because this is in parentheses, this whole group, and it's raised to that negative exponent, I'm going to take this whole quantity and move it to the other side of the fraction. That's like taking the reciprocal. So this becomes 1, and just remember, see, this is kind of like a 1 here. 1 times anything is itself, so there's just a 1 left in the numerator, and then this whole quantity, 2x to the 4th, is now a positive exponent. So again, you can think of this as a 1 and a 1, power to power you multiply, so we're getting 1 times 4 is 4, and 1 times 4 is 4. But 2 to the 4th is 2 times 2 times 2 times 2, 4 times, which is 16. So this simplifies to 1 over 16x to the 4th power. And for number 12, what did you get on this one? You can do this a couple different ways, but what I like to do is just multiply across like this. So x to the 7th times x to the 2nd. When you multiply, you add, so that's 9. And here, multiplying, same base, we add the exponents, that's 15. When we divide, we subtract. Now remember, it's important the order. You take the numerator's power minus the denominator. So 9 minus 15 is negative 6, but you can think of moving this to the other side of the fraction because of the negative exponent and make this 1 over x to the positive 6. Another way to look at this is x to the 9th is like 9x's multiplied together. X to the 15 is like 15x's multiplied together. And 9 of these in the numerator are going to cancel with 9 in the denominator, leaving 6 left over in the denominator. Or you could kind of say like 9 of these cancel with 9 of these, leaving 6 left over. See, that's how that ends up in the denominator. Okay, so you're the brave ones still with me here. See if you can do this next group of problems. We're getting a little bit more challenging. So we've got number 13 here. Let's see, how would you do this one? We've got 5 over 3w all raised to the negative 2. Well, what I would do when I see this negative exponent, see that negative tells me to take the reciprocal of the base. This whole thing is the base. So what I'm going to do is I'm going to flip it over. I'm going to say this is 3w over 5 now, but it's raised to the positive 2nd power. And then again, remember, you can think of all these as having a 1 in the exponent if you don't see an exponent. So it's really like 1 times 2 is 2, 3 squared is 9, and 1 times 2 is 2, so that's w squared, and then 1 times 2 is 2, 5 squared is 25. So you want to make sure you apply it to the numerator as well as the denominator. Okay, for number 14, what did you get on this one? You've got negative 2x divided by 3, the quantity squared. Now notice we have a negative squared. That's a negative times a negative. So this is going to be a positive, and 2 times 2 is 4, so this comes out to 4. 1 times 2 is 2, so that's x squared. And there's a 1 there because there's just 1, 3. 1 times 2 is 2. 3 squared is 9. Okay, so we've got that one. Number 15, what do you think on this one? Now you've got a couple options. You could try to reduce what's inside the parentheses first, and then raise it to the second power. Or you could just go ahead and raise it to the second power and then simplify after. Either way, you're going to get the same answer on this problem. So which way do you want to do it? Well, let's maybe simplify what's inside first. So this is understood to be a 1. When we divide, we subtract. So 1 minus negative 2 is like 1 plus 2. So that's giving us x to the third power. And then negative 2 minus 7, that's really giving us negative 9. So that's negative 9. And then the 5 here is still in the denominator. Now that whole thing is being raised to the second power, which remember, if you don't have an exponent, we can put a 1. And I'm just going to apply this 2 to each one of these quantities here. So power to power, we multiply. So 1 times 2 is 2. 3 squared is equal to 9. 3 times 2 is 6, so x to the 6. Negative 9 times 2 is negative 18. And 5 to the first, of course, 1 times 2 here is 2, and then 5 squared is 25. Now, the only thing we need to do here is we have this negative exponent, which is just affecting the y. It's not affecting this whole quantity here, just the base, just the y. That's not in parentheses, so it's just affecting that base. We can move that to the other side of the fraction and make it a positive exponent. So this is going to come out to 9x to the 6th all over 25, y to the positive 18 now, and you got it. Number 16, we've got a lot going on in this problem, so if you get this one right, you've really mastered these exponents. What I would do is a couple things. First, I have this negative. I would take the reciprocal of this base. So let's go ahead and do that. That would be like y cubed over 5x squared. Now instead of negative 2, this becomes a positive 2. Okay, that's good. Here what I'm going to do is I'm just going to, power to power, I'm going to multiply the exponents. And don't forget about the 2. This is understood to be a 1. So that's going to come out to 3 times 3 is 9. So we have x to the 9th. Negative 4 times 3 is negative 12. 1 times 3 is 3. So 2 cubed is 2 times 2 times 2 is 8. And this is z to the first. 1 times 3 is 3. So we have z cubed. Okay, so it's getting a little bit simpler. We've got this power here as well. So we're going to apply that to each of these exponents. So power to power, we multiply. So that's going to give us y to the 6th. And this is going to give us 1 times 2 is 5 squared, which is 25. And 2 times 2 is x to the 4th. Okay, and that's all multiplied by this quantity. So let's just rewrite that. X to the 9th, y to the negative 12th, over 8z to the 3rd. Okay, now what I would do is I would just multiply the numerators together and denominators together. So if we do that, y to the 6th times y to the negative 12th is going to give us y to the negative 6th. The x to the 9th is still in the numerator. I usually like to write it in alphabetical order, like A, B, C, X, Y, Z, from left to right, like that. 25 times 8 is 200. So let's put that there. And we've got x to the 4th and z cubed. Okay, now it looks like we're dividing. So when you divide, what do? You subtract. So 9 minus 4 is going to give us x to the 5th. Remember, when you do the quotient rule, you always want to put the answer in the numerator. So 9 minus 4 is 5. If it came out to a negative 5, on the next step I would take the reciprocal and move it to the denominator. This y to the negative 6, I'm going to take the reciprocal and move that to the denominator. So that's going to come down here. And z cubed is still in the denominator. And the 200 is still here in the denominator. So it looks like that's as far as we can go on that one. Okay, see if you can do this next batch of problems, 17, 18, and 19. Go ahead and pause the video and we'll go through them. But for number 17, what did you get on this one? Well, here what I would do is a couple different options. You could simplify each of these fractions and then multiply them together. But I think here what I'm going to do is I'm just going to multiply the numerators together, denominators together, and then we'll simplify after that. So here what we have is we have 2 times 3, which is 6. And we've got x to the 1st times x to the negative 1. Remember, when there's not an exponent, it's a 1. So 1 plus negative 1 is 0. And y to the 1st times y to the 2nd, we add the exponents when we multiply, so that's y to the 3rd. In the denominator, we have 8 times 1. That's understood to be a 1. There's not a number in front. X to the negative 2 and z to the 4th. Okay, now here we're dividing, right? So this is just like a fraction, 6 and 8. You can reduce this. You can say 2 goes into 6 3 times, 2 goes into 8 4 times. X to the 0 divided by x to the negative 2, when you divide, you subtract. So 0 minus negative 2 comes out to 0 plus 2, which is just 2. So that's going to be x squared up here. The 3 is up here. The 4 is down here. Y cubed is here. And z to the 4th is still in the denominator. Now another way to do this is you could say x to the 0 is equal to 1. And then this x to the negative 2, because it's a negative exponent, we can take the reciprocal and move it to the other side of the fraction bar. That's another way to look at it. Okay, for number 18, what did you get on this one? Well, you can see again here this x to the 0. Now notice it's not 5x the quantity to the 0. There's no parentheses around the 5x, so it's just x to the 0 here. This is just 1, and 5 times 1 is 5. Well, let's go ahead and do our power. So this is like a 1. 1 times 2 is 2, so that's 5 squared, 25. And this is like a 1. 1 times 2 is 2. 2 squared is 4. And then negative 3 times 2 is negative 6. Now, we don't want that negative exponent, so we're going to move this quantity to the other side of the fraction and make this 25y to the positive 6 all over 4. And then for number 19, this one, what can we do? Well, notice this 2x is in parentheses, and it's a negative exponent. So I'm going to move this whole thing to the numerator and make this 2x to the positive third over 1. And that's all multiplied by 4x. Well, actually, let's see if we can simplify that. So this would be a negative exponent here. So that means we're going to take the reciprocal. So this is really going to be 3 over 4x all to the positive 2 now. So that negative exponent, I took the reciprocal or flipped that base and raised it to the positive exponent. Okay, here what we can do is we can power to power, we multiply. These are both understood to be 1. So 1 times 3 is 3. 2 cubed is 2 times 2 times 2, which is 8. 1 times 3 we said was 3, so that's x cubed all over 1. Here we've got 1 times 2 is 2. 3 squared is 9. And here we have a 1 and a 1. So power to power, you multiply. 1 times 2 is 2. 4 squared is 16. 1 times 2 gives us x squared. And then what you can do here is you could multiply, but you can also do some reducing, numerator and denominator. Like 8 goes in here once, 8 goes in here twice. You could think of 2 of these x's canceling with 2 of these, leaving 1 left over. That's a nice way to do it. So this is going to come out to 9 times 1 is 9. We've got x to the first, or you could just say x. And then we have 1 times 2, which is 2. So that one's simplified down quite a bit. Okay, before we dive into this last example, which is quite challenging, but I think you can do it, I just wanted to let you know that if you like the way that I explain things and you want to check out more of the content that I put together, I have 2 courses for sale. I've got links in the description, an Algebra 1 video course for sale and an Algebra 2 video course for sale. So check those out if you're interested. See if you can do this last problem on your own. Let me know in the comments if you were able to do it. So if I was going to do this one, I think what I'm going to do is I'm going to start by simplifying what's on the inside first. So what we're going to do is when we divide, remember we subtract. So negative 2 minus 1 is going to give us x to the negative third. And 3 minus 5 gives us y to the negative second. Remember, when you do that quotient rule, the answer stays in the numerator. And that's all raised to the second power. Now, let's see if we can simplify this one a little bit. This one, you can see the 3 and the 9 reduce. So that becomes a 3 here in the denominator. Okay, and then 4 minus 1 gives us x cubed. And negative 2 minus negative 3 is like negative 2 plus 3, so that comes out to y to the first. And that's all raised to the negative third power. Now remember, power to power we multiply. So I'm going to multiply all these exponents by 2. I'm going to multiply all these exponents by negative 3. So let's do that. So 2, this is 1 times 2, which is 2. 2 squared is 4. Negative 3 times 2 is negative 6. Negative 2 times 2 is negative 4. And 1 times 2 is 2. Now 7 squared is 49, so we'll just write that as 49 and simplify that right now. Okay, over here, power to power we multiply, so that's going to be x to the negative 9th. 1 times negative 3 is negative 3, and 1 times negative 3 is negative 3, so this is 3 to the negative third. Okay, now what we're going to do is we're going to multiply horizontally across. So what I'm going to do here is I'm going to say 4 times 1 is equal to 4. And negative 6 and negative 9, when we multiply, we add. So that's going to be x to the negative 15th. And y to the negative 4th and y to the negative 3rd, when we multiply, we add. So that's y to the negative 7th. And then over here, the 49 I'm going to leave in the denominator. But the 3 to the negative 3rd, because that's a negative exponent, I'm going to move it up here. 3 cubed is 3 times 3 times 3, that's 27. So I'm going to move the 27 up here to the numerator. 27 times 4 is 108. And I'm going to move the x to the negative 15 down to the denominator because of that negative exponent. Same thing with the y to the negative 7th. I'm going to move that to the other side of the fraction because that negative exponent, we take the reciprocal. The 49 is still down here. Looks like we have all positive exponents, and we've simplified it as much as we can. So great job if you were able to get this one correct. I'll put another video right there if you want to follow me along and do some more practice with exponents. I'll see you over in that video.